Hello everyone, hope you are doing good. This is the ninth tutorial of the course Computer Programming in C++. This week we will be covering user-defined functions. We will also do a tutorial on built-in functions later in this course. Okay, so what is a function? The simplest way to tell what a function is in programming will be function is just a piece of code that does something for you. It takes some input and does something on it, and it gives you some output. So the more important question is why a function. We will see functions in detail in few minutes, but the more important question is why functions? Why do we want to use functions? We have learned to program normally. We can write code lines. What's so good about functions that we need to use them? Why don't we just code normally? Why do we need functions? So that's more important. So for that, suppose you have to calculate the cube of a number. You have to write this code for some logic in your program. Suppose that you have to do this, and while programming, after a while, you need to calculate this cube again. And then after a while again. So maybe you have to calculate the cube in your program for like 5 times maybe. So instead of doing that, what we can do is, instead of writing this code again and again, what we can do is we can write this code at some point in your program and then use it. So what I'm talking about is actually that maybe this is your program, and maybe for some in some lines, maybe some 4 or 5 lines, you had to calculate the cube again and again. So instead of you had to write these lines again and again. So instead of doing that, maybe you wrote these lines somewhere, and then instead of writing them again and again here, instead of doing that, you just used this piece of code in the place of all these lines. So instead of writing again and again, you just you wrote these lines in some point in your program, and then you used these lines at these points where you needed to calculate the cube. So again, how is this helpful and why functions? For that, imagine you have to make a huge project with a large number of lines of code, and you have to calculate the cube at maybe some 50 positions, some 50 points in your code. So obviously it is convenient to write the definition of cube, write this functionality of cube, this code of cube at one point, and then use it in all those 50 places in your code, 50 points in your code, instead of writing this line at each of those 50 positions, 50 points in your code. So this covers the first point, that it avoids the repetition of same code. Instead of repeating this line again and again at different places, you just write it at one point and use this in all the places where you need the answer of this line, where you need to calculate the cube. The second thing is code reusability, right? So for now, it may seem that this is just one line. What's the point of writing it at one place and then calling or using from that place? Because it's just one line. But maybe the function that you are writing of some huge project may be a huge function, right? Maybe the function itself, the code that you want to reuse again and again, itself has a lot of lines of code. Maybe it's that, right? So suppose that you don't have to calculate the cube, you have to do a lot of other things again and again. And suppose these are some 20 lines. So imagine writing these 20 lines at all of those 50 positions in your code, at all of those 50 points in your code, right? So that's not very convenient. So if you write them once in a function and then call or use these lines of code from all those points in your program, then it's obviously more convenient. And this is known as code reusability. You write the code once and then you reuse it in all those places. The third point is making your program modular. This is actually a very important point, and let's see it properly in detail. So let's clean this up. Okay, what do we mean by modularity? Modularity means writing your code in huge chunks, writing your program, writing a big project in chunks which are integrated with each other in some way. And if you make some changes in one chunk, in one module, that will not affect the other module, that will not affect the other function, other chunk. So if you may do something in one thing, its changes does not affect the other chunk or the other module. That way, you can easily write code in modules that can be integrated with each other later. This may seem a little bit tough for now. Let's take a simpler example and see this thing in a more simple way, right? So let's clean this up. Okay, now imagine you are making a huge project, and that project has some 30 files of code. See, 30 different files of code, and each file has several lines. And in that project, I'm just making 5 files here. So in that project, you needed to calculate some number x, and for that you had some formula with you, right? And maybe that x had to be calculated at some in each of those files, right? In some random positions in each of those files, maybe. So each line represents where I have to calculate the variable x with some formula. So you did that, and then later on you realize that this formula was not correct. This formula had some error in it. Something was not right. Instead of maybe multiplying, you divided or something like that. So you did the formula wrong. Now you have to correct it. So for correcting, you will have to go to each and every of these lines where you had written that formula and change it. You will have to do changes at each of those lines, right? So how tough is that? Imagine there are 30 files and you have to change that formula in each and every one of those 30 files in different places. How tough is that to go and change it manually at each of those positions? So if you had written a function right here and you had written that formula in that function for x, and you had called that function from all of these files, instead of writing that code for this formula manually in each and every one of these, you had just used a function and called that function from those files. Then if you realize later that this formula was not correct, then what you will have to do, you will just have to make a change right here, just single one change right here in this function. So you will just make one change and it will not affect all those files. That formula will be changed in all of these because this function is being called from all of these files, so you don't have to go in each and every one of them and make changes, right? This is a very important point. So functions give us modularity. We can write code in modules. We can, if we change something within this function, most probably it won't affect these files unless you have done some huge blunder. That's another thing. Okay, so to achieve these things, we make a function. To avoid repetition of the same code, to implement code reusability, and to make the program modular, to have modularity, we make a function. Now let's see a function properly graphically. So this is the abstract view of a function. What a function is. A function has some input. You can imagine it like a factory. It's a factory. It's doing something. You give it something, it does something. It cooks inside it, right? It does something here, and then it outputs us. So it gives us an answer. What it does inside is actually the code that you write inside. So the example we took before in the previous slide was the example of a cube. So of a cube. So if you have to multiply a number 3 times and get a cube, this is the inside of that function. This is what the function will be cooking or doing, right? So this is actually this part, the inside of a function is the part where we write our code, our algorithm, our formula, whatever. So function takes some input, it does something with that input, it calculates some maybe some formula, and then it gives us some output. So this is what a function is. Now let's see it in detail. Let's see the functions, how to declare a function, what is the syntax. Let's see all those things in detail.